Linux powers pretty much everything these days, from massive servers to tiny devices all across the globe. But have you ever stopped to wonder how a single operating system can speak hundreds of different languages or understand all the different ways we write dates and times? Well, today we're going to break down the really elegant system that makes Linux a truly universal language. So let's start with the basic problem, right? Imagine you've got one server. Maybe it's sitting in a data center in New York, but it has to work perfectly for a global team. Someone in Tokyo needs to see dates in their format, your finance team in Paris needs to see the correct currency symbols, and everyone needs system messages in a language they can actually read. How on earth does Linux pull all of that off? Well, it all comes down to two core ideas. First, you have internationalization, and you'll often see it shortened to I-18, which is just a nerdy way of saying there are 18 letters between the I and the N. This is all about building the potential for the system to adapt. Then you have localization, or L10N, which is the part where you actually do it, setting the system to German for a user in Berlin. One is the blueprint, the other is the build. Okay, so the absolute foundation of this whole system is something called a locale. You can think of it as your system's digital dialect or its regional identity. So what is a locale? It's really just a collection of settings. It tells all your programs everything they need to know about your preferences. Things like how to display money, what day of the week comes first, and even how to sort lists alphabetically. And you can see this for yourself. If you pop open a terminal and just run the locale command, you'll see a list of these settings. Each LC variable controls a specific category, right? LC monetary is for currency, LC time is for dates, and look closely at the value itself. It's got a clear structure: language, country, character encoding. That little string is the key to everything. Okay, and here's a super important point. There's a hierarchy to how these variables work. At the bottom, you have lang, which is your general catch-all default. But you can get more specific. Let's say you want your system in English, but you need to see currency in euros. You can just set LC monetary. The specific LC variables will always override lang. And then there's LC all. That's the boss. If you set LC all, it overrides everything else. It gets the final say, no questions asked. Now, just setting the language is only half the story. The system also needs a way to understand what those characters actually are in ones and zeros. And that brings us to the really crucial topic of character encoding. So, way back in the day, we started with ASCII. It was great for English, but that was about it. It couldn't handle characters with accents or symbols from other languages. So then we got standards like ISO 88859, which added more European characters. But the real game changer was Unicode, a single universal standard designed to represent basically every character from every language in the world. And UTF-8 is just the most common and efficient way we use Unicode today. It's the standard for a reason. And this is what happens when things go wrong. If your system is expecting a file to be in one encoding, but it was actually saved in another, you get this: unreadable gibberish. There's actually a great word for it in Japanese, mojibake, which literally means garbled characters. But when the system's expected encoding matches the file's encoding, like when both are using UTF-8, everything just works. It displays perfectly. And that simple need for consistency is exactly why having a global standard like UTF-8 has been such a massive leap forward. So, what do you do if you get one of those mojibake files? Are you just stuck with it? Nope. Thankfully, Linux gives you a powerful tool called iconv. It's a command line converter that can read a file in one encoding and write it out in another, fixing all that garbled text in an instant. It's a real lifesaver. Okay, the final piece of our localization puzzle is time. For any computer, but especially for a server, having the correct time isn't just a nice to have. It's absolutely critical for things like log files, scheduled jobs, and just about any kind of network communication. Linux handles time zones using a pretty standard file structure. The heart of it is this directory, /usr share zone info. It's basically a giant database of all the world's time zones. To set the time for your system, a special file is created at /etc/localtime. And usually, this file is what's called a symbolic link. You can just think of it as a shortcut that points to the correct time zone file inside that big database. So, what's a quick and easy way to see what your system thinks the time is? Just type date into your terminal. That's it. The output will give you the full date, the current time, and importantly, the time zone abbreviation it's using, like PDT for Pacific Daylight Time here. Now, on any modern Linux system, the standard, proper way to manage your time settings is with the timedatectl command. Instead of messing with those files by hand, you just run a command like timedatectl set-timezone America/New York, and it handles creating that symlink and all the backend stuff for you permanently.
All right, so we've seen all the individual pieces of the puzzle. Now, how do we actually configure these locale and time settings and make sure our changes are permanent?
You basically have two main options here. If you just want to make a temporary change, say you're testing a script and need to see how it behaves in a French locale, you can use the export command. That change will only last for your current terminal session. But for a permanent, system-wide change that's going to survive a reboot and affect every user, you'll want to use a tool like Localization.
So let's do a quick recap of your essential toolkit. You've got locale to check your current settings. You use localect and time date control to set them permanently. If you're not sure of the exact name for your time zone, tselect is a really handy script that will walk you through finding it. And of course, iconv is your go-to tool for fixing any of those pesky file encoding issues. Okay, so what's the bottom line here? Let's quickly go over the key takeaways and talk about why getting this stuff right is just so important. Getting these settings wrong isn't just a small annoyance. It can cause some serious real-world problems. The wrong character encoding makes your data totally unreadable. The wrong time zone can make debugging from log files an absolute nightmare because you have no idea when anything actually happened. And mixed-up locales just lead to a confusing and inconsistent user experience. So, to wrap this all up, I want to leave you with a classic real-world scenario to think about. For maximum clarity and no confusion, server logs should always be in UTC, but your users need their business reports generated in their own local time. How would you use the tools and concepts we just covered to make both of those things happen on the very same system? The answer to that is where you see the real power of understanding Linux localization.